For those of you that are familiar with factorials, it is well known that a factorial, n factorial, where n is a non-negative integer, and by non-negative integers we mean 1, 2, 3, and so forth. And of course, 0, because 0 doesn't have a sign, it's neither positive nor negative. So some actually count 0 as a non-negative integer, so they can put 0 in here. However, again, we could argue either way. So if you stay with 1, 2, 3, and so on, this would be the set of positive integers. Now, the definition of factorial, I have it up here. It's given by whatever n is, the product of n and every natural number up to 1. Notice it stops at 1. The factorial stops at 1. It doesn't go to 0. And textbooks that introduce the idea of factorials typically tell us that by definition, 0 factorial equals 1. They say notice it's called by definition. I have that in quotations. Now here's how some people prove that 0 factorial equals 1, in that they start by saying 1 factorial is product of 1 times 0 factorial. Well, this definition actually doesn't fit that, right? It doesn't look like that, because with this definition, the original definition, we stop at 1. It doesn't go to 0 factorial. Okay, so right there, some students, again, I've done this myself too in the past, and students, some of them have issue with this. And they say, well, you're trying to show 1 factorial, 1 times 0 factorial. The question is, what is 0 factorial? So if I say 1 factorial is 1, which is everybody, that's how they prove this, is 1 times 0 factorial, divide both sides by 1, and you get 0 factorial equals 1. And there you go. They say the proof is complete. Again, however, this, to me, it just doesn't feel right. It doesn't seem right. And part of that, again, that I have personally issue with is right in here, is that for definition of factorial goes up to 1. So where does that 0 factorial come from? Unless we attach a 0 factorial at the end of this, but then now we have to actually show what 0 factorial is. Nonetheless, again, in textbooks, we say by definition, 0 factorial is 1. Now, in this video, because then you're going to say, well, how are you going to prove this? I'm actually going to use a valid mathematical technique to show this. Okay. Now, the proof of this involves the gamma function. This is the actual valid proof that I'm personally comfortable with, and I see it as a valid proof. So let's start with actually a well-known, I'm just going to call it a well-known fact. Now, this well-known fact actually could be proved, and in fact, I can prove this for you in another video. Perhaps I do it, and if I do, I'll put the link below the comments for you so you can see what this well-known fact, the proof of this well-known fact is. And the proof is, or the well-known fact is this, that for any, if n is a non-negative integer, then gamma of n is equal to n minus 1 factorial. And in fact, more broadly in textbooks on probability theory, they say n is integer. So I'm just going to stay with n being a non-negative integer here. Okay. Now, therefore, for example, when n is 1, gamma of 1 is going to be 1 minus 1 factorial, and that is 0 factorial. Aha. Therefore, 0 factorial is equal to gamma of 1. Now, this is not by definition. This is actually based on this well-known fact that you can prove, and I'm going to show you a proof for that and put it in the comments. Okay, so at this point, I need to determine what gamma of 1 is, right? So let's go to actual gamma function. The general gamma function looks like this. The gamma of n is defined as the integral from 0 to infinity of t to the n minus 1 e to negative t dt. Okay, so that is what the gamma function is. Now, I want to evaluate gamma of 1. right? So gamma 1 is going to be 0 to infinity of t, replace n with 1. That's 1 minus 1 e to negative t dt. And of course, t to 1 minus 1 is 0. So this segment, t to 0, is going to be 1. So this actually, the integral reduces to 0 to infinity of e to negative t dt. Correct? So that's what that ends up being. Now, all right, now let's actually rewrite the right side. Now, if you notice the right side here, the integral is what we call an improper integral. The improper integral, and the reason it's improper because the upper limit involves infinity. So in order to evaluate gamma of 1, I'm going to write this as the limit as, let's say, a goes to infinity of 0 to a of e to negative t dt. And usually this is how we handle improper integrals, because the reason is because we have to have limits of integration that are numbers, not infinity. If we keep infinity, then we run into issues with the fundamental theorem of calculus. So that's to keep the fundamental theorem of calculus happy. All right, so how are we going to work this one? Now, at this point, we're just going to write this as limit a going to infinity of, now, we can evaluate the integral of e to negative t. I'm sure everybody knows how to do this one, is negative e to negative t, and evaluate it from 0 to a. All right, now, of course, I can bring the negative outside and simply do limit as a goes to infinity of e to negative a minus e to 0. And at this point, I'm doing the fundamental theorem of calculus, the upper minus the lower limit. Now, if we take the limit here, the limit of a difference would be difference of limits. So it's going to be negative. The limit of e to negative a as a goes to infinity, just quickly, if you recall, this is what the graph of e to negative a looks like. And of course, let's say that is a. Instead of x, I have a now. So as a goes to infinity, the function is approaching 0, right? So the first limit of e to negative a, sorry about that. So this first limit is just going to approach 0. And of course, then we have e to 0 over here, which is 1. And the limit of a constant, 1 in this case, notice it doesn't depend on a. So a goes to infinity, that limit's going to stay 1 because it's a constant. It's going to be negative 1. And in other words, there you go. So gamma of 1 is 1. Now notice we did establish this validly through the procedure we just did. So we know gamma of 1 is 1. Therefore, gamma of 1 is going to be 1 minus 1 factorial. Remember this expression we have up here? So I'm going to that well-known fact. Okay. Now what is 1 minus 1? On the right side, that's 0 factorial, and gamma of 1 is 1. We just proved that. And there you go. This is the actual formal proof that 0 factorial is equal to 1, and one that doesn't rely on the definition of factorial. Again, this, I've seen it, I've done it myself, but I stopped doing this actually personally. I'm not doing this anymore because, again, 1 factorial in this form is 1 times 0 factorial, and we haven't resolved what 0 factorial is. So, and the definition of factorial up here stops at 1. It doesn't go to 0 factorial. That's why the books say by definition 0 factorial is 1. So there you have it. This is a short video, and I just again want to show you that. I'm going to go ahead and do the proof of this well-known fact that gamma of n is n minus 1 factorial, and I'll put it in the comments. All right. I hope you find this useful, and thank you for watching.